Good afternoon, everyone. So, I'm pleased to introduce the expert of our today's third session, Dr. Anish Gandhi. Sir is works as principal and professor in mechanical engineering of C.K. Pichawala College of Engineering and Technology, Surat. Sir is expert in the field of intellectual property rights, specifically in the field of patent search, patent drafting, patent prosecution, patent portfolio management, registration of industrial design. Sir has professional experience of more than 22 years in the field of academics, academic administration, and research in engineering, particularly mechanical and manufacturing industries. Sir has published more than 60 research papers, edited one book, guided more than 15 ME projects, and 7 PhD dissertations. We are pleased to have Sir with us. Thank you very much, sir, for providing your valuable time. So I request, sir, to please give us some glimpse about innovation and IPR for Industry 4.0. Thank you, sir.
Okay, thank you, Vivek. Let me first of all say submitting my gratitude of thanks to the RNG PIT for giving this opportunity for knowledge sharing.
Right.
To
Thank
the
you.
Latesh Chaudhary sir, to all the coordinators. Let me start with my today's session. See, basically, if I more clearly clarify the title, so let me share my screen here. Vivek, I hope screen is visible to you.
Yes, sir. Screen is visible, sir.
Okay, so today's topic is innovation and IPR for Industry 4.0. Specifically here, I will be covering a major part on say what are the challenges as far as the intellectual property rights are concerned when we talk about the Industry 4.0. I have gone through your other sessions also that was also related to Industry 4.0, I think previous to this. So I hope that various types of patent and certain other things might have been discussed in that part. So basically, my today's talk will open up us a huge area for people who wants to work in the Industry 4.0, or maybe who are looking at say in the intellectual property rights as far as the Industry 4.0 is concerned. So specifically, whatever we are going to discuss, this is what we can say is basically a brainstorming sort of a topic. But as we are at a distance place, maybe that effectiveness may not be there as far as the brainstorming is concerned. So I'll be delivering from my side what are the various challenges as far as the Industry 4.0 is concerned when we talk about the intellectual property rights. So to start with that, if I talk about the content, so content covers Industry 4.0, that is in terms of the introductory part. Then we will be talking about Industry 1.0 to 4.0 transition. See here, we need to understand that what additional elements are added when we talk about the Industry 4.0, when we talk about in reference to Industry 1.0 to 3.0. So that is a very, you can say the interesting part and important for all of us. Then I will be talking about some, say one short video, which will talk about say a case of the digital enterprise. So which will cover almost all, you can say silos of various Industry 4.0. Then we will be talking about Industry 4.0 in Indian context. So what industries are doing, what sort of government policies are available and how it has been changed. So, and as far as the academias are concerned, what changes are going on. So in that way, we will try to understand Industry 4.0 in Indian context. Then we'll also talk about the three groups of technologies for Industry 4.0 according to the European Patent Office. Then we'll talk about Industry 4.0, what are the global statistics in terms of, say, patent filings in the various domains, and which are the countries who are, say, leading in a particular technological area. Then what are the new challenges to IP system, that is intellectual property system, and innovation policy in the digital era. So that will be our main focus as far as the today's talk is concerned. And of course, we'll talk about some references. So again, say when we talk about the Industry 4.0, it is also known as we know that a fourth industrial revolution, or Industry 4.0, or I 4.0. This is basically bringing together the different silos of the production system via. So we are talking about different aspects like a network, then allowing the real-time data sharing, and facilitating machine to machine and human to machine interaction of unprecedented speed, at unprecedented speed and scale. So here when we talk about various silos of the system, it talks about the different aspect in terms of hardware. So as an example, the network. Then when we talk about some machine and machine to machine or machine to human interaction, so we are talking about again some hardware. And another part which is very important here is a data. So we are also talking about the certain soft form, and data sharing of course is a very important. So now this is giving rise to the seamlessly integrated value chain with interconnected cyber physical system. So this word is very important as far as Industry 4.0 is concerned. What is cyber physical system? We will also try to understand in our today's talk in some later on part. So we are talking about interconnected cyber physical system which enables the decentralized decision making and unprecedented levels of automation. Of course, this we will understand when we'll go through that short video, said what sort of industries we are talking about when we talk about the digital industry. Then the digitalization of the entire manufacturing value chain, starting from a procurement of raw material and extending right up to the customer service using mobile services, communication networks, sensors, and actuators, is completely transforming how the world factories operate. So in Industry 4.0, what has happened, okay, which has changed or which has transformed the way in which the various factories are operating. So we will understand that when we'll talk about the addition of, say, various you can say the element as far as when we move from 1.0 to 4.0. Now, when we talk about adoption of Industry 4.0, then what are the benefits to the manufacturer? So these benefits includes cost reduction and improved efficiency. So when we see a cyber physical system, it can monitor the factory processes and make decentralized decision, which enables the faster processing. We can say a connected factory is capable of taking automated self-corrective measures in the instance of errors. Say we are talking about here now these self-corrective measures. So we are talking about the adaptive systems which adapt to the situations. Of course, when we talk about the adaptation, there is a requirement of one very important element that we talk about in terms of AI, that is an artificial intelligence. So we'll also talk about that in certain part of this today's discussion. Then technologies such as a 3D printing, a laser technology that allows the better utilization of the resources such as a soft floor and thereby adding to the operational efficiencies. Of course, we are today talking about 3D printing a lot because of the various advantages which are associated with. We are also talking about the laser technology. Then this leads to the cost saving, then better productivity and faster time to the market. We all know that 3D printing technology has changed say the way in which we were producing the prototype earlier. Okay, so of course from say when we talk about some small product to even construction of building, now people are talking about the 3D printing. So now another advantage is a value addition. So first advantage we were talking about cost reduction and the efficiency. Another advantage we are talking about is a value addition. So digital manufacturing technology such as 3D printing, laser cutting, CNC machining centers, let me say, then various robotic technologies allow manufacturing of the product in a small batches, thereby allowing for the better customization, quality, and value addition. Okay, now whomsoever is from the say mechanical field, and those who have already learned these subjects may be related to the say CIM, computer integrated manufacturing, or maybe say automation. So we always talk about two important aspects. One, what we call it as a say flexibility, and another what we call it as a say automation. See, when we look at the flexibility, achieving the flexibility, this is very easy to achieve when we talk about general purpose machines. So you can very easily do the changes in the design, you can do the changes in the volume of production what we are going for. So you can easily change the route, okay, or the sequence of manufacturing as far as the general purpose machines are concerned. On the other side, we are talking about the automation. So in the automation, we are reducing, say, or minimizing, or maybe we are now talking about eliminating the human intervention. These both are opposite to each other. When we talk about highly automized technology, of course, it is at the cost of, you can say, the flexibility. And when we try to achieve the flexibility, say it will be at the cost of automation. But today, a lot of things has changed. Even you will realize in the video what we are going to say go through today. We are sitting at our home as a customer, say we are designing our own car. So we are giving say large number of different out of available combinations of our own customized cars, and companies are delivering within say a reasonable time. So this is the today's era. And then the question is how this can be achieved where both the things will exist together. That is in terms of flexibility as well as in terms of the automation. And if you can do that, then only you will be surviving in the today's market, because customers are highly demanding. They want everything at the time at which they want it to be. Okay, not you cannot have a much more say stretch delivery times. Customers also demand for the better quality, which is of course at a lesser cost. So there's a huge pressure from each and every side. Then we are also talking about another advantage, that is in the terms of health and safety of the factory workers. So by eliminating the need for human presence and intervention in the certain high risk tasks and environment, Industry 4.0 can help the manufacturer to avoid exposing workers to the health hazard and reduce the fatalities on the factory shop floor. Even nowadays, we are seeing many plants, okay, where the plant is in operation, but you will not find a single, say, human on a shop floor or maybe on a plant. People are sitting maybe inside some control room. Maybe they are not in control room, but they are maybe at their own places, and they are continuously monitoring on the basis of the various digital devices and the platform what they have. Even with the help of the mobile phones also now people can easily monitor what is going on, and even no need to monitor. If something going wrong, then immediately there may be a pop-up or the messaging, and looking to that, even say certain corrective actions can be taken. So this is the era in which we are now walking. So let us understand how we achieve this particular part of things. So now let me talk about the industry 4.0 to industry 1.0 to 4.0 transition. That is also known as the rise of the connected ecosystem. So when we talk about first industrial revolution era, of course, whatever has been written is on an average you can talk about. There may be some say variation in this. So industry 1.0, that is first industrial revolution, witnessed the exponential growth of machinery, mechanization in the production with the help of water and steam power initially. Before the first industrial revolution, manufacturing was done with a simple tool, and there were unskilled workers who worked under, you can say, very tough conditions, unbearable conditions. So you can say 1.0 means certain machineries has been introduced and power of water and steam has been used. Then second industrial revolution, it has witnessed electric power generator replace water and steam power engines. So production of the electricity. Then large scale production, large factories such as a steel revolution in manufacturing factory. Advent of the assembly lines were introduced at that time, and electric power revolution, say even telephone as well as refrigerator, washing machines were introduced during this particular era. You can see the photograph. This is, you can say, the first factory where assembly line was introduced. Okay, this is again from one of the car manufacturer, and you can talk about the say first telephone. Okay, so which was introduced in this particular era. Then third industrial revolution, when we talk about, okay, this is also known as a digital revolution. There is some typographical mistake here. This is 1970 to 1999 it has been. So when we talk about the you can say the digital revolution, it is characterized by automating production and information technology. So now we move towards the automating the things, or we have moved towards the automation. Even we know about the soft automation, hard automations. I am not going into that detail. So comes with the enormous change in the industries with digitalization that transform manufacturing and automation. We know that it has a whole change, or it's a great transformation, and it has changed a lot of things. Even there was a lot of disputes. Okay, say people have come up with some thread that when we talk about the automation, it will replace the human jobs. Then when we talk about this period, it has witnessed the exponential technological changes, like even 3D printing was introduced very earlier. It is not a today's concept. You can find the patterns which are on 3D printing, which is even before this particular time. We were talking about the big data, modern technology in mechanical devices instead of analog electronics. So analog to digital transformation, you can talk about as far as this particular area is concerned. Then we are talking about Industry 4.0, also known as a 4IR or Industry 4.0, is witnessing a drastical and exponential change that is transforming how the people working with the devices. So now say we are talking about working of people with the devices, how they are working. We are also talking about how devices are working with each other. So we are talking about now interaction between say machine to machine, or machine to machine interaction, and human to machine interaction we are talking about. So now this has transforming say that is transforming how the people working with the devices, like maybe the computer to the electronic devices, working and helping the human being. The fourth revolution or industrial revolution is a continuation of the third industrial revolution that was categorized with digitalization and automation manufacturing. We are now talking about on a large scale introduction of the robotic technology in, you can say, the wide spectrum, even starting from the manufacturing industry to the service industry. It is very common in the certain part of the world today to come up with the restaurant which is completely operated and serviced by say robots. Similarly, we'll also come across the various factories where a complete production system is handled by the robots. We are also talking about, say, a Sophia, which is the world first robot citizen, as we are all aware of. So now let us understand based on this diagram that what sort of complexity or what sort of elements which has been added when we move from first industrial revolution to the fourth revolution. So in the first industrial revolution, we were talking about, say, mechanical assemblies. Okay, that is mechanisms driven by the steam engine and water. Then when we talk about the second revolution, we are talking about introduction of the electronics. Okay, maybe to operate a mechanical assemblies. So assembly line led mass production with the use of electrical energy. Even this was the case. So electrical power was also introduced, right? Then the third industrial revolution we are talking about another element, that is IT and automation control. So mechanical assembly, then electronics, and then we are also talking about IT, that is information technology and automation control. So we are talking about the various control systems now. Then fourth industrial revolution, we are talking about additional element, that is in terms of or in the form of embedded and connected information technology with interaction with the physical system. This is what we call it as a cyber physical system. Okay, so we will have some definition of this. So this is how you can understand that what are the additional elements which has been added when we talk about industry 4.0 is concerned. So when we talk about industry 4.0, coming together of a digital and physical world and digitalization of manufacturing processes based on cyber physical system. As an example, we are talking about now IoT, that is Internet of Things. So where you can say various physical systems are operated, okay, remotely as per the want of the user, right? So that is what we can say is an example of a cyber physical system. The fourth industrial revolution is a cyber physical system characterized by physical, digital, and biological sphere, which is transforming and impacting all the work life, say, including economics and industries. I think Vivek, I am audible to all of you. Everything is going well. Vivek is there.
Sir, your voice is audible, sir. And
Yes, yes, everything is going well.
yes, sir, everything is going well in smooth direction.
Fine, fine. Okay.
Okay.
So now when we talk about industry 4.0, it is witnessing the growth of 3D printing. Okay, so now we are talking about what are the areas, okay, where there's a huge scope for working when we talk about the growth of industry 4.0 or introduction of the industry 4.0. So we are seeing the growth in the 3D printing technology. Lot many things are going on. A lot of people are working on, say, how a metal can be printed using 3D printing in order to get the metallic components. So that is a huge challenge. Then intellectual property. Of course, we are going to address this in much detail. So what are the challenges or what changes may be required when we talk about the industry 4.0 in terms of an intellectual property? Say intellectual property means we are not talking about only the patents. We are talking about all the intellectual property rights, whatever is available in India. Then we are also talking about, say, artificial intelligence, then smart robots and automation technology, quantum computing, then Internet of Things, drone technology, blockchain, use of big data. So, of course, anyone, okay, who is maybe working in the field of research, or maybe it is important for an industry as well to say address or to take an opportunity to work on any of this particular technology, because it will have, of course, a great say impact on the society. Okay. Now, when we talk about the industry 4.0, key technology levers and their roles, again, already we have listed. So we are talking about introduction of, say, Internet of Things. So that IoT enables the real-time machine-machine interaction by connecting them over a network and help the establishing the connected value chain. We are talking about big data analytics, where a data analytics capabilities to support intelligent and real-time decision making. Then cloud computing. So cloud computing offers a platform equipped with say vast computational storage and real networking capabilities. See, even today we are talking about say replacement of even servers. Okay, people are not say going for establishment of the server in their own institute or maybe the industry. Everything is say operated on a cloud. Then additional manufacture, say additive manufacturing. So additive manufacturing helps the production in small batches in a cost and time efficient way, in a cost and time efficient way, by reducing the lead time from the product designing to the product release, and improves the customization. See, if you talk about the era which is say maybe the 20 years back, so if you try to go for the statistics that within 1 year how many two-wheeler models were introduced or how many four-wheeler models were introduced, and you talk about the today's era, every day you may come across that one new model, maybe more than that, of a four-wheeler or maybe a two-wheeler has been introduced in the market. So of course this has been possible because of this reduction in the say lead time, starting from even initial conceptualization to commercialization. Then augmented reality. So augmented reality could enhance the business operations by leveraging the mathematical modeling, artificial intelligence, and virtual reality. We are talking about AR, VR. Even by sitting at home, okay, you can just visit some furniture online store and you can take the photograph of your own room, or maybe you can have your camera on and you can place that particular furniture article in your room, okay, on a virtual platform. So this is all possible because of AR VR now. Robotics we are talking about, that is interconnected robots to facilitate the automation of the manufacturing processes. Cyber security helps establish secured communication protocols. See, this is again a very important area where a lot of things require to be done. Okay, cyber security, a very, very, very important part. Suppose we are talking about in near future that on the roads, maybe all the vehicles or maybe the large percentage of the vehicles which are, you can say, a self-drive type of vehicles. Suppose if there are certain people who takes the control of those particular self-driving type of cars in their own hand, you can imagine what may happen. Just before 2 months, you might have come across that there was some cyber attack on one of the say oil industry in the US, and a whole supply chain, okay, was disturbed by those people, and of course they had demanded for a huge money, and they required to be uh, say say people required to surrender to these particular people. Then we are also talking about M2M, that is machine to machine, okay, and involves the use of the industrial instrumentation sensor and record the communication data directly with the software. So here, see, now we are talking about two things. If you talk about one thing, that nowadays the time is such that whatever the innovation you will come across, there's a maximum chances that it will have some software, some algorithm to operate it. Of course, when we talk about say software, only even software will not work. There should be presence of some physical system. So we are talking about this system, okay, as an example, like you can talk about the today's four-wheeler. So a lot of things are automated as far as the four-wheelers are concerned, okay, and say automatic climate control inside the car, this is one, okay. Then you can have many more features which are there, and of course the time has gone. We were talking about the luxury car which were giving only 2 to 4 kilometer per liter as a fuel efficiency, and now it has increased maybe up to 20 to 30 kilometer per liter in that particular range. So Of course, many operations are controlled automatically. Some control cards are already there in the today's four-wheeler. So now let us look at one of the example of Industry 4.0. It's a very interesting example to go through. Of course, this is from the Siemens company. Anybody can even visit later on also on this particular website.
Let's be honest. The world has changed a lot over the past few years. Today, you can configure and order electric scooters online and name your preferred delivery date. New products, faster, more personalized. Yeah, the things we like to do for fun present major challenges to companies all over the world. From personalized production to mass producing one-off items and getting new products to market with lightning speed. Securely and flexibly, of course, delivering exactly what the customer wants with consistently high quality at affordable prices, while always looking for new ideas to generate more business. This takes true entrepreneurial spirit and a whole lot more. Product development, automated production processes, and digitalization must go hand in hand in order to create a company that can do all this. In other words, a true digital enterprise. A digital enterprise? Digital enterprises. Great. What does that mean? It means looking at things holistically. The products, machinery, processes, the entire plant, complete production, and the way everything performs. Not just the hardware, but most of all the data models and software solutions. Only by combining, processing, using, and continuously optimizing virtual and actual information can you come up with something new, something better. This is what we call the digital enterprise. And there is only one company that really excels at this. Siemens. We do equally well in a variety of industries, whether it's brewing beer, mixing paint, producing medicine, or assembling cell phones, airplanes, or cars. Why is Siemens so good at this? Siemens has mastered the principle of digital twins, which means it has something special to offer. Picture this. You want to produce a new soft drink or modify an existing recipe. Okay, the first step is to experiment with the recipe and then simulate, optimize, and test the ingredients digitally across the board. Of course, your drink needs a cool bottle and an eye-catching label, both of which you can also design digitally. You can then use this data to simulate the bottle and make sure it's stable enough, all without having to build expensive prototypes. Once you're happy with your product, you have to plan its production. What machines to use and with which functions? How do they fit with your existing equipment? How do you organize the flow of goods, employees, workflows? You can now do all this digitally in a process called the digital twin of production. It's faster and more efficient, and of course, there are also fewer errors once you switch to the real world. You can transfer information, tests, and processes to actual machines and entire plants with the press of a button. We even have cool technologies that let you digitalize existing factories. And of course, we have an automation portfolio like no other. Siemens calls this
totally integrated automation,
because everything is interconnected and therefore delivers huge quantities of valuable data. Totally integrated. So now production is up and running, and we are creating a tremendous number of wonderful products and generating lots of data, which must, of course, be protected. The digital twin of performance is our term for all operating and production information, as well as information about the finished product. The good and sometimes the not so good data flows back into the virtual product and production planning processes. thus continuously optimizing the entire system. We have cool cloud-based analysis tools and trailblazing new technologies that keep making everything better and more transparent. And if you don't know where to start, don't worry. Siemens has digitalization service experts who can guide you on where and how to take the first step. Once you've done all this, you have built a digital enterprise. And that means that everything will now be much faster, more individualized, and of the highest quality. It's good for customers, and it's good for the industry. To sum it up, a multitude of software tools and products must, of course, all work together. And Siemens has a name for this, the digital enterprise. No one else can offer this, really. And suddenly, when you hear someone say,
Realize your digital transformation now.
it all makes perfect sense. The digital enterprise. Only we have it.
Siemens, ingenuity for life.
So when we talk about this particular ad, say always I consider to be one of the best, I can say, the video to explain about the industry 4.0 when we talk about the digital enterprise. So you have seen that this is particularly the company which is offering you the solution in establishing the digital enterprise, and a lot of examples they have given on which they have already worked upon. And you might have seen that it has touched each and every domain, starting from the conceptualization to the design, and then to the simulation, and then say testing, and coming up with the manufacturing facilities. So many things already you have seen. And of course, you have also seen in the video they were talking about some say fruit juices to some Cadbury. Then they also talk about the manufacturing of, say, the airplanes and many more things. So this is, I always consider a base example to explain. So when we talk about the industry 4.0, so how the India Inc. is gearing up for a change. Because when we talk about the industry 4.0, of course, we will not be successful if we continue the way in which we were already working or we are already working. So what changes you are in need of? So how you have to prepare yourself? So globally, the industry 4.0 market is expected to reach, say this is in terms of Indian rupees, so that is 13.90 lakhs crore, okay, by 2023. Countries such as US, China, Japan, and European nations such as UK, Ireland, Sweden, and Austria have all started adopting 4.0. See, name of country is very important. Now, why it is important? Say when we talk about, suppose some intellectual property search, suppose the patent search, okay, related to the industry 4.0. So which patent offices publication you should attack upon? So from this particular statistics, you will get a lot of idea. Then in India, the sixth largest manufacturing country, the manufacturing sector forms an integral part of the country's long-term vision, as seen by the government's strong focus on Make in India campaign. So we have come across this campaign from our government of India. The government aimed to augment the share of manufacturing in GDP to 25% from currently approximately 70%, okay, by 2022. So by this campaign, of course, government want to increase the share of manufacturing in the GDP. Then a number of initiatives and policy reforms such as implementation of the GST, easing the FDI policy, it has been taken care by the government. So many things has happened, many change has taken place. Okay, of course, when you come up with some campaign to achieve the particular target, lot of reformations are required. So of course, in successive slides, we are going to discuss some of the notable steps taken by automotive manufacturing towards the industry 4.0 can be understood by say one of the example, say where we are talking about the technology known as a cobot. So cobot, this is basically the short form of collaborative robots. So collaborative means they can collaborate with each other, okay, to come up with some manufacturing solutions. So one of the largest manufacturer of the two-wheeler, you can see here, it is the Bajaj, right? In India has installed the cobot at its plant to automate the assembly line. Several processes such as material handling, welding, deburring, bolt tightening, sealant application and machine tending were collaboratively handled by the cobots and plant employees. So there is a, you can say, interaction between collaborative robots and plant employees. So it is a machine to human interaction or human to machine interaction. So what were the benefits? So this lead to the enhancement in the productivity for a company. Say production rose from 507 vehicle per person per year to 804 unit per person per year while maintaining the existing standard. So this is how it has benefited the particular industry, you can see. So 3D printing technology is also established. The largest two-wheeler manufacturer of India is using additive manufacturing for the product designing of all two-wheeler parts for fitment and functional testing. So this has helped the company to reduce its time to market. See, earlier when you want to come up with one prototype, it was taking a long time, and as well as it was say very costly affair. But now because of the 3D printing technology, it is easy to come up with the say very customized type of product or a component, whatever you have designed. So now this is one of the photograph from the Bajaj, okay, where they have installed. There are some robots, as you can see, at each every workstations along with the human beings over there. Okay, so they are working in close collaboration. Then other sectors are also say picking up as far as adaptability of the industry 4.0 is concerned. So this is one of the example for use of the industry 4.0 in the textile. The intelligent plant framework has been introduced by a Mumbai-based multinational company. Okay, for what purpose? To connect all the machines and examine the rate of work and efficiency. The framework allowed to reduce the wastage and organize the production flow. Then, as far as the packaging is concerned, a connected machine technology was introduced. So the Bangalore-based packaging company has connected machines over a network that provide a monthly dashboard about the machines. It helps the company put a predictive maintenance in place. So this is again, you can say few of the examples of use of industry 4.0 in the manufacturing. So what are the steps taken by the government in India to promote the adoption of the industry 4.0? Of course, you are going to identify many of these say steps which has been taken. Lot of reforms are there even in as far as the academics are concerned, as far as the syllabus formation is concerned, as far as the new introduction of the new courses are concerned. So when we talk about say National Manufacturing Policy 2017, so the government rolled out a new policy to push the manufacturing share to 25% of GDP by consolidating Make in India initiative with focus on adoption of the digital platform for Industry 4.0. Then a national program on the artificial intelligence was introduced. So the union budget again 1819, the government announced that Niti Aayog will create a roadmap for National Artificial Intelligence Program focusing on developing a new AI application. Then Center of Excellence on Information Technology and Industry 4.0. So this COE would act as a knowledge center for entrepreneur and startup and propagating the concept of IT and its application in Industry 4.0. See, nowadays even government is helping in coming up with some say centers, okay, to support the industry. I think that is what we call it as a common facility center. Say one of these centers is also available or going to establish at even RNG who has organized this particular say program. So likewise, government is talking about the COE establishment, not only to support the research of the university or the colleges, but also any industry can visit to that particular center for their own R&D related requirement. Then mission on cyber physical system. So as per the Union Budget 2018-19, the Department of Science and Technology will launch the CPS mission to support establishment of the COE for training in robotic, AI, digital manufacturing, etc. Because see, now we are talking about the digitalization industry 4.0 where These areas will be very important: robotic, AI, digital manufacturing. So now skill requirement for the industry 4.0, how it has changed. So what are the skill requirements? So digital knowledge and ability to work with the data, that is the prime requirement. Then another requirement is a cross-functional expertise and soft skill. So now ability to use the automated system, knowledge of new age technology such as IoT, AR, VR, machine learning, big data and analytics, knowledge of cyber security and data protection, statistical knowledge and ability to analyze the data generated from the machine. Then cross-functional and soft skill requirement includes understanding of the cross-functional processes, focus on client need and industry trend, expertise in working under the ambiguous and the changing environment, honing soft skills such as collaboration, emotional intelligence, decision making, and upskilling mindset. See, the days has gone now where one person is joining some industry and when they retire, okay, they are working throughout their 40 years of or 35 years of their service life. Okay, maybe on a same sort of the machine, same sort of technology. Those days has gone now. Everything is changing very fast. Of course, a person has to keep on learning continuously if they want to even not grow, but they want to sustain. Okay, otherwise they may get an obsoleted. So these are the new challenges. Now, what is the role of government, industry, and academia in upskilling the country? So let us talk up first of all the academia. So as an academic, people have to talk about enhance the quality of the teacher and modernize the learning infrastructure. So there is a much more pressure on this. Say a very fast changing, you can say machines are there. Technology is changing fast. As far as the computer IT is concerned, okay, we have to continuously update the syllabus to meet the requirement of the industry. So these are the new challenges. Align courses and curricula in tandem with industry 4.0 requirement with well regulated and industry relevant updated content. Focus more on practical, result oriented knowledge over the theoretical content. So now already you are seeing that change from say theoretical classroom to say even intensive based learning, where there are some intensive which has been made compulsory even in the syllabus, even by the AICT also. Then promote a culture of research in upcoming areas like industry 4.0 and act as a test beds for innovation and new learning. We all know that now government is promoting as far as the innovation is concerned, and a lot of fundings are available now for a proof of concept, developing the prototype, even to file the say intellectual property protection. Then we are talking about the participate actively in the development of massive open online courses. So many options are available now. Okay, NPTEL is one of the example. You can register yourself to the particular course. You can learn, okay, whatever you want. Okay, even it may be a cross disciplinary for you because it is a requirement now. Collaborate with the industry players. Okay, Bangalore based reputed academic institution is setting up a smart factory in collaboration with the global aerospace major. If you look at a countries like China, okay, even near to the Bharuch, I have came across one of the plant, okay, which was completely designed and established by the undergraduate student of one of the institution of the China. So this is like because of the collaboration. Okay, so that collaboration we need to bring up on as far as our Indian system is concerned. Now, as far as the government is concerned, take a job creation initiative like Make in India, which is expected to create a 10 crore jobs. Then involve a private sector in a PPP model to conduct industry 4.0 relevant training. Launch mass skilling initiative like a Skill India. So Skill India initiative is also there, which aims to skill about okay a large number of Indians. Of course, on which? On the various developing technological or need-based technological area. Then create a proper infrastructure and develop the innovation center and test lab. Provide supportive policies and adequate financing for the skill development. Promote practice and industry oriented training. improve quality of academic institution and vocational training. Of course, government has to take a lead, okay, to improve the quality of this particular various universities and academics. So what will be the role of industry? So create and define the new role of industry 4.0, which will be mostly managerial in nature. Provide reskilling opportunity. Already we have discussed that a lot of things are changing. Things are changing very fast nowadays. So there should be an opportunity for each and every individual working in the industry to develop themselves. Provide cross-functional exposure to the employees. If you talk about, there is one, say, corporate, I am not giving the name here, but what is the policy there? The policy is every 3 years they keep on changing or transferring the employee from one department to another department. Like as an example, initially they may be employed in say purchase department, they may get transferred in planning, then maybe in design, then in manufacturing. So the day will come where a single person will have a knowledge of a whole system as a say enterprise, and this is very much important. Now participate actively in PPP initiative, okay, to take up the vocational training with the government. Undertake and invest in R&D for industry 4.0 technology. Of course, if you look at the percentage of investment of GDP as far as the R&D is concerned in India, it is very less. Okay, so we need to do a lot of things on this particular aspect. So these are the three groups of technology for industry 4.0 according to the European Patent Office. These technologies are core technologies, okay, then enabling technologies and application domains. So these are the three groups of technology which has been defined by the European Patent Office, that is EPO. So core technology embodied in connected object. So hardware, as an example, the sensor. Software, examples are adaptive databases, intelligent data storage. Connectivity means a network protocol for connected devices. This is coming under the core technology. If you look at the patenting in the core technological area, you will be looking at patent related to this particular aspect. Then enabling technologies, that talks about the artificial intelligence, 3D printing technology, adaptive security systems. Application domains such as smart manufacturing, smart home, smart city, these are the few examples. So which are the application areas, the domains in which this has been introduced? What are the global statistics? Why it is need to understand, of course, if you want to search for, if you want to understand what are the opportunities, okay, you need to go through the statistics. So the number of patent applications in technologies related to the industry 4.0 began to rise in mid 1990, increasing from around 300 in 1995 to 944 in 2000 and to 5500 in 2016. In 2016, there were almost twice as many patent applications in industry 4.0 than in 2011. So you can see the growth. The share of all applicants at the European Patent Office is small. In 2016, they constitute 3.3% of all European patent applications, but grow from 1% in the 1990. So you can see here, still a percentage contribution of the innovations which are related to the industry 4.0 to the total number of innovations for the patent application is filed is very less. There's a huge scope in this particular area. Inventions in industry 4.0 technologies at the EPO have been dominated by USA, Europe and Japan. The increase in patent application in industry 4.0 is driven by limited number of applicants. So we are talking about now applicants. Who are the applicants? So these are very limited. In 2011 to 2016, a group of 25 applicants accounted for 48% of all applications in industry 4.0 filed at European Patent Office. Out of top 25 applicants at the European Patent Office in industry 4.0 technologies, there are 12 Asian companies, 7 are from Japan, examples are Sony, Panasonic, 3 from China, some of the examples are Huawei Technology, Okay, ZTE, 2 from Korea like Samsung, LG, 7 from US were there in this 25. Some of the examples are there: Qualcomm, Intel, Google. 5 companies are from Europe like Nokia, okay, Philip, Ericsson. 1 from Canada, BlackBerry. So this talks about the total 25 applicants. So you can see the country. Still, you can say, if you talk about the industry 4.0 related inventions, these are, say, related to some concentrated geographical locations. About 30% of the patent applications come from inventors from Europe. In Europe, there is a strong geographical concentration of Industry 4.0 patent. Germany is leader in Europe, followed by France and United Kingdom, followed by the Sweden, Finland, Netherlands, Switzerland. So again, this is important when we talk about the searching the database, okay, related to the particular field of technology. So now we are talking about the 3 different domain of Industry 4.0. So in core technology from Industry 4.0, European countries are the strongest in connectivity. So country names are there like Denmark, France, UK, okay, and weakest in hardware. So these are strongest in connectivity, weakest in hardware. In enabling technology, Europe is quite strong in artificial intelligence. Okay, name of the countries are given here. And security, but has relative lower position in energy supply. In application domains, European countries rank highly for invention in vehicle and infrastructure. Now, let us come to our core aspect, that why protecting innovation through the patent. So this is very common question. To benefit those who have knowledge and inventive power. Of course, so this is the major, you can say, the reason. To benefit those who have knowledge and inventive power, and inventive to encourage the innovation, an incentive to encourage the innovation. So this will act as an incentive to encourage the innovation. To increase the cost of access to those without knowledge or inventive power by limiting the use of innovation, a monopoly of the innovator, etc. So these are the major reasons why to protect, okay, through the patent. So conclusion. How is a digital revolution changing the role of patent in protecting innovation? So that is very important now. We are talking about a digital divide, a different innovative modes, innovation versus imitation and diffusion. So these 2 are very important. Say, you may come across one topic that when you can circumvent, then why to invent? So what do you mean by circumvent, or what do you mean by circumvention? Working around an existing invention is what we call it as a circumvention. So you may take one existing technology, you may thoroughly go through the detail of that working principle, the construction, and you will try to come up with, okay, a solution which is much nearer to that by circumventing or by working around the existing invention by coming up with a small changes. Okay, so that has become now a very common, and that can be done easily in comparison to the say new innovation. So the big question is, if you can circumvent, then why to invent? Then another thing is a diffusion. So we'll also go through that detail. In fast developing digital industries, a protection of the innovative solutions has been changing. This is very important. Protection of the innovation solution has been changing. Innovators might not be interested in protecting new solution through the patent. Too much time is needed to finalize the patent procedure. So you might have some knowledge about the patent. Say if I talk about, say before the 2019, okay, an average time which is required from filing of the patent to the grant is approximately 7 years. Now, already government is working on this. many new examiners are recruited and new facilities are created, and this time is now reduced to average 2 to 3 years. And there are some other options are also available for say you can say expedited examination of the patent application which has been filed. Now on the one side we are talking about the technology which is very fast changing. Okay, maybe after the 6 7 years when you get the patent, okay, technology say you can say obsoleted, then what you will do with that? Okay, so the time taken in order to grant the patent, that is it has a major role as far as the decision related to that is concerned, and people are discouraged because of that reason. Protection of digital innovation might not be possible, like big data use, computer programs. So already you have attended some of the lectures and you know that as far as the section 3 of the Patent Act is concerned, it talks about the non-patentable subject matters. So when we talk about the computer programs, okay, this is coming under the category of a non-patentable subject matter under section 3K. Okay, then diffusion and imitation of the innovation is faster than before. Of course, we are living in the digital era. Okay, data transfer is very easy. It is possible. I am sitting here and we are communicating, okay, by sitting at a different geographical location in a real-time basis. So when we talk about because of all this, okay, because of the cost of say data sharing has gone down, because of the better technology and faster machines availability, because of the better say network which are available, now the data sharing has become very easy. Okay, so anything whatever is coming new diffuses very fast to the other part of world, and when it is happening, of course there's a great chance that imitation of that or copy of that. And what are the new challenges to the IP system, that is intellectual property systems and innovation policy in this particular digital era? So this we need to understand, right? All encompassing and rapid transition to the digital environments are related to artificial intelligence, robotic and big data, 3D printing, Internet of Things, industrial revolution, industry 4.0, you can say. What are the new challenges to IP system and innovation policy in the digital era with reference to? So we need to understand that what are the challenges in this era of industry 4.0 in reference to various intellectual property rights such as patent. Okay, then in terms of the brand and design, so we are talking about the design protection, we are talking about the trademark, then copyright and related right. Then what about the what is the challenges in terms of intellectual property economics, then intellectual property law and rule, then intellectual property enforcement, then intellectual property office administration. So we will try to look at these all aspects, that what are the challenges in next say 10 to 15 minutes. So when we look at the patents, okay, so the challenge in the face of transition to the digital environment, it is worth considering how the patent system might impact advances in artificial intelligence. On the other way, it is worth considering how artificial intelligence might impact the patent system in terms of claim construction, inventorship, requirement to patentability, and enforcement. So now look at here. I am giving you some detail about the inventorship. Say, as far as the patent is concerned, so patents are granted for a creation of the human mind. Okay, say human mind. This is very important. Human word we are using here. Nowadays, we are talking about artificial intelligence, where we are creating the artificial minds. They work and they improve over the period of time. Okay, so when we talk about say a self-driven car, some AI based system is there. So with the increase in the, say, number of kilometers for which it has been used to run the particular vehicle, it continuously keep on improving by learning. You might have come across some news where people have developed some model, okay, which can be run on, say, certain computational machines, some algorithms, and that helps in reducing, say, vaccine development time. Because when we talk about the development of any medicine or vaccines, a lot of formulations and combinations are required, but this helps in reducing the time. So again, now the question is, whatever is the creation of the, say, machine mind and not a human mind, then how to protect it? Another thing is, suppose if such a technology is created, say some first artificial intelligence technology is created, now whatever the creation of that particular artificial mind, then who will be the owner? Another thing is, suppose there's a use of artificial intelligence, okay, suppose self-driven car is there, some accidents has happened on the road, some say people have been aggravated because of that, then who is responsible? Okay, who should be punished? Who should pay for the compensation? Whether is that machine, or whether it is an owner of that particular technology, or say owner of that particular car, or whether it is a person who has introduced that technology and offered to you. So there are a lot of issues which are going on. Claim construction, of course, very important, because there are non-patentable subject matter, and we are talking about, of course, use of algorithm. Without that, even AI will not work. So then how to construct the claim? Okay, that is a very challenging task. So I talked about inventorship, I talked about then how to enforce, and let me tell you in some other classes also. Now, what about the brand? So what are the challenges when we talk about the brand in this particular digital environment? So new digital technologies alter the fundamentally the traditional way the brand and design communicate reputation and image value. We are talking about now non-traditional trademark protection. Suppose as an example, many times we are seeing the or coming across an animated logo. So can we go for protection of that animated logo? Okay, then brand protection in the domain name system. Of course, a lot of disputes are going on here. As an example, suppose Tata is already one brand. Now you are going to register, say, a domain name for yourself, and you are selecting that particular name. Should it be allowed? Okay, and how it is to be taken care that we are not, or one person is not registering the certain name, okay, which is maybe associated with some other brand. Then use of the brand in the social media. So we are nowadays having the presence on various different social medias. Can I use a certain brand, okay, on the social media without taking any permission? Nowadays people are very freely accessing the things and even sharing the things. So what is legal? Up to what extent it is allowed? What law says? Then protection of the country name, geographical indication, and names of the geographical significance against the unauthorized delegation as a domain names. Again, we are talking about the domain names. Okay, so these are the certain challenges as far as the protection of the brand is concerned. Now, what about the design? So we are talking about the industrial design protection. New digital technology impact the design of product. Transition from hardware design to the digital interface. Design protection for graphic user interface, icon, and type of font. So nowadays, even we are not talking about only the component which is existing physically. We are also talking about producing some three-dimensional object which are in the digital form. So can we protect that, an innovative design which is there in a digital form? Of course, okay, no answer to this particular, say, requirement at this moment. Then copyright and related rights. So when we talk about the digital environment, the digital technologies have reshape the way the content is being produced and consumed. Say earlier we were talking about only the say printed mediums. Nowadays we are talking about many digital platforms, and they are providing the content only in the digital form. We are talking about even the books nowadays which are simply in the digital form, and tablets are offered with certain inbuilt digital books only. The global distribution of the creative content is online, on demand, and at a distance. So there is no limitation now as far as the distance is concerned. With just one click, you can share any content with any person who is residing at any geographical location in the world. So global distribution of a creative content which is online, on demand, and at a distance. New players and transforming the business models have emerged both at national and international level. Of course, with the digitalization, lot of say hard forms has been stopped. So then how to take care of that? A new global creative market has been shaped and some challenges arises. How to ensure that developing and least developed countries can access and participate in this global market? How to create an adequate enabling infrastructure in the form of legal framework, management tool, market conditions, so that the developing and least developed countries can fully embrace the digital challenges. So here we are talking about even equality at a world level also, to give the equal access to the developing and least developed countries. Now, what are the challenges in terms of the intellectual property economics? So when we talk about the digital technologies have transformed the value chain in the creative industries, say book, newspaper, music, movie, video game, photography, etc. New players have emerged, notably so-called the digital content platforms, and bargaining positions are shifting. Earlier, it was not like that. Digital platforms were not there, but now many things are available only on the digital platforms. Key questions to consider. How does digitalization affect the total supply and the quality of the creative work? What are the effect on the sales via different distribution channel and revenue from the experimentation with the new business model online? What are the effect on variety and availability of the work supplied on the market? Can global reach of platform create entry opportunity for new talent, including those from the developing economics? Or will virtual trade enhance a superstar outcome whereby the most successful reap the most gain? See, nowadays, of course, opportunities also increase. We have come across that a small person from a particular maybe any of the region of the any of the country, maybe it is a rural region also, they can have their own virtual shop, and they can start operating from that virtual shop, and they can supply the things to the any part of world. But again, when we talk about all this possibility, the cross country economics, the cross country rules plays an important role. So what are the challenges in terms of participating in the global production? So new digital technologies, as an example, the robotics, 3D printing, big data, artificial intelligence are transforming global value chain. They may undermine the export competitiveness of the developing economics in the international commerce in some cases and create a new entry opportunity in others. We all are familiar that even AICT model curriculum and even AICT handbook, if you look at, so they introduce now 9 emerging areas. These are all related to this. If you just read over here, 3D printing, robotics, big data, AIML, that is artificial intelligence and machine learning. So again, why? It is just to prepare the nation for a next era of a manufacturing, and that is what we call it as a digital manufacturing. So if you want to grow, you should have the manpower. You should have the expertise, you should have a people to work in that particular area. The key questions to consider: how will new technology affect the incentive for locating a production to the lower wage developing economies? See, we have a great opportunity now, as we know, that a lot of manufacturing facilities are shifting from China to the India. Okay, from China to India. Of course, there are many other factors, but of course, we have to take an advantage. How can developing economies acquire a new digital technology so that their companies can participate in transforming global value chain? So, are you available to offer the services to the industry what they want to enter into this particular geographical location? Are we available with that expertise? Are we available with that social setup? Are we available with that particular laws and tax and other governmental regulation requirements? So, what role does IP play in this context? It is very important. See, if some company is entering into your region, say in India, they are establishing their own, say, R&D facilities. They are coming up with their production. But if they are not protected strongly with the IP laws, okay, and whatever they have introduced, people can copy without much impact, then of course nobody would like to enter into for the purpose. So how strong IP protections you are, okay, providing, that is also a very important. What are the elements of successful innovation ecosystem that allows developing economics to take advantage of newly arising opportunity? What skill do developing economics need to invest in? There are a lot of opportunities in terms of IP administration, intellectual property offices administration. Nowadays, people are talking about, say, patent search and many other things that you can do now sitting at your office, sitting at your home. Okay, just you should have one computer facility, maybe mobile is also enough with net connection. Just imagine the era 20 years back. Of course, we were not available with such a great and fast internet facilities. Even the various documents were not digitalized at that time. So once as they were not digitalized, how they can be accessed? So can you imagine if I want to do the patent search before the 20 years, how it is possible? Okay, of course, it was very difficult. People may require to visit to the patent office even. Here, when you talk about now, everything is available on a click. Okay, but to make it available on a click, you need to have a digitalization. You have to convert all your records into the soft form. Nowadays, also we are available with the facility called the PCT facility, Patent Cooperation Treaty. Okay, we are also available with the convention route by which we can enter into the say any of the country for filing of the patent by maintaining the you can say the priority based on your basic application. So how the data transfer takes place from one patent office to another patent office. See, these are all very important. So weak technical digital infrastructure, the lack of digital intellectual property data, and lack of access to the digital data of intellectual property and scientific literature. Intellectual property offices need to strengthen information and communication technology system and business solution for benefiting from digital technology to enhance the efficiency of the services. The lack of digital data at intellectual property offices owing to the paper-based IP procedure. So these are the some of the challenges. Of course, a lot of things require to be done. Lack of digital content and platform to share intellectual property files with the other intellectual property offices. The advent of AI will further widen digital divide among the intellectual property offices and intellectual property related institutions. Capacity building for working in the digital environment is needed. Limited access to non-patent and patent literature in digital format, including lack of patent analytic tools. Say, I want to just make you aware of one thing. When you go for a patent search, two types of databases are available. One is a paid database, another a free database. So free database is available from various patent offices across the world. Whereas paid databases means this is available in the form of the software. Okay. They are provided with the patent analytics tool. So they can fetch the data from the large number of patent offices, maybe all the major patent offices all over the world, okay, related to your, they will help you in order to build the search query. Not only that, they will provide you the strong patent analytics tools, so that the time and efficiency for patent search, okay, efficiency will increase and time for the patent search will go down. Then, of course, there are a lot of challenges as far as the intellectual property enforcement is there. See, unless and until you will not enforce your right, there is no meaning to go for it. So, online copyright piracy and trademark counterfeiting, exacerbated by the ease, speed, and low cost of making and distributing unauthorized copies online and engaging in the counterfeit e-commerce. So on Amazon, suppose you are putting some of your product, maybe possible on the next day you will find the same product on some other platform also, or maybe in some other shop also in the same platform. So the copying has become very easy because of easiness with which we can share the information, we can access the information. Difficulty in identifying and prosecuting the infringers. Suppose we are talking about a copyright violation. You are here and somebody has violated your copyright somewhere in some other far, say, geographical location of the world. How to catch them? Okay, what cost will be involved? So all these things we need to take care. Cross-border online infringement, territoriality issue, role of internet intermediaries. Can it be possible to say sue the internet intermediaries who has provided the platform for this particular type of the sharing? Then issues specific to developing and the least developed countries, like legal framework, capacity constraint in terms of the financial, human, judicial, administration, and technical. Then there is one more important part, that is IP, intellectual property, and judiciary. Say government is now in India emphasizing more on, say, IP filing. It is but nature, with the increase in the IP filing, even the litigation case is going to increase. So that is going to increase a case load, okay, on the judiciary system which are related to the IP violation or IP related issues. Are our judiciary system capable to take care of that? Up till now, we were talking about intellectual property appellate board, okay, which has come into the existence from the 2007. It has been operational initially for the trademark, and same was then extended to the patent also. But now it has been discontinued, and only at a, say, Delhi High Court, one cell has been established, which is particularly related to the IP bench is established, which is particularly handling the IP related cases. So complex multifaceted disputes requiring effective remedies that reconcile the territoriality of the IP right and judicial structure with the transactional and online nature of the growing volume of IP disputes. Concerning novel questions arising from technological changes that may not have been envisaged and addressed by the legislator or the society, involving emerging actors, including online intermediaries, generating increasing volume of cases at increased cost of courts. So with this, we just try to address that what sort of challenges people are going to face as far as the uh, intellectual property protection is concerned with the industry 4.0. So with this, let me conclude here, and I am just handing over the session, okay, to the organizers here.
Thank you very much, sir, for in-depth knowledge about uh, that IPR. Sir, many of the academicians have joined this workshop, and you have a very excellent experience in the field of academics. So, sir, what is the actual importance of patent uh, in respect to academics, means for academicians, sir?
Okay. See, patents are always important whether it is an economics or the commercial field. Specifically, patents are granted for commercialization. The reason is, if you are given the patent rights, it will be at some social cost. Because you are given the right, no other people can operate on that right. So this is also called as a negative right. Even in the Patent Act, okay, it is specified that if you are not commercially exploiting, there is a chance that your patent right may be stopped. Now, as far as the academic institutions are concerned, if you just go for the survey of the various foreign universities, okay, large number of patents are created, okay, which are commercialized, and they are earning, you can say, a large revenue out of these particular patent rights what these universities have. As far as the fees and other things are concerned, if you compare with the revenue which has been generated out of this patent, it's a huge. As a being academician, okay, we are guiding our young students in some technological domain, maybe as a part of their undergraduate projects, maybe as a part of their MTech and ME, or maybe as a PhD. So of course, if we say acquainted with the types of the intellectual property rights which are available, and from very beginning, if we have that particular mindset, we can also come up with some technology, some innovation, which may have some commercial market. And once it will happen, I am for sure, okay, only for a money, the person would not require to work. There will not be any restriction if you have come up with a very good, say, innovative technology which has been patented. If you are not patenting and directly publishing your work, then what is happening? You are giving it at free of cost to the society. Anybody can go through your concept, can use that concept, can commercialize and can earn. But once you file the patent, if you protect it, and then you should go for the publication. Now, as you are available with, say, patent right, other people can read it, can learn out of it, but they cannot go for the commercial use. There are large number of examples even from the India where something has been created at a university level, maybe at an institute level, and okay, a lot of revenue has been created because of the technology transfer. You can take certain case studies from the IITs, from IISc Bangalore, where certain type of things are going on. Of course, as far as the even point system is concerned, like NIRF, or maybe other, say, NB accreditation, or maybe some other, maybe accrediting bodies. Of course, in terms of patent, also as an individual faculty, you will have some upper hand on that particular aspect. But of course, commercialization is a very important part which we must take care.
Right.
And even if you cannot commercialize, at least go for protecting it.
Exactly, sir. Right. And so for PhD scholars, what you advise that the scholar should first go with pattern or publishing of paper in well-reputed journals?
See, first go for filing of the patent application and then go for a publication.
Right, sir.
But then whatever the research they have done, they cannot file the patent application.
Okay.
So in order to qualify to file for the patent application, they first of all need to understand what is patent and what can be patented. Not
Right.
only that, when they are performing literature review, we are always going for only the non-patent literature review, like we are referring to the journal papers and magazines and other things. Nobody is going for the patent search. It is happening that large number of data are available in the form of the publication, in the form of the patent literature, which is not published in any other journals or literature. Because as an academician, we want to have an advantage of that particular publication. We are going for publication in the journals. But otherwise, if you talk about the company, okay, they have only the concern about their patent rights. So they are filing the patent and it will be published only in the form of a patent literature. And then they are not going for publication in any other journal or maybe the magazine or a literature. So it will not be available to you.
Exactly, sir. Right.
So from a very initial period, from starting from literature review, if you focus on even the patent search, definitely your end results or end output of your whole research will change.
Hmm. Right. Exactly, exactly. Thank you very much, sir, for your precious time. On behalf of RNG Patel Institute of Technology, once again, I thank you. Uh, Dear participants, tomorrow also we have scheduled session of Anish sir, and Anish sir will be talking on drafting IPR for computer-related inventions. I have already shared feedback links on your chat section. So I request everyone to please provide your valuable feedback. So thank you very much, sir.